So let's talk about this idea of statistically significant or not being statistically significant, and the relationship between a hypothesis test decision and the connection to the interval, okay? And if the how that null hypothesis relates to that interval. So we can actually, so we know this statistically significant is essentially saying then that what we would be doing is, so then our sample is in the rejection region. Okay, we have a statistically significant sample that is in the reject because it was very unusual and in the rejection region. Okay, so then that leads us to a lot of different things based on that idea there. And then, of course, if it is not statistically significant, then our sample is not in the rejection region. Okay, and this all goes along also with your relationship to alpha, which we'll talk about. Okay. So there's kind of the basics of keeping those ideas in mind. So let's talk about each one of these. All right, so we're going to label which goes where. So if I'm failing to reject, that is because my sample was not in the rejection region. Okay, so then I'm going to put that number 1 here, failing to reject, which means my rejecting statement is here. Now, you do have evidence to support the alternative versus you do not have evidence to support the alternative. Okay, so let's think about that. It is when I reject HO that I do have evidence. So that would be there. And so I do not have evidence to go with HA. Okay. And then, of course, here's our p-value is lower than alpha. Okay, so our being lower than alpha, that's number 5. That, of course, is in our rejection region. So number 6, it is not lower than alpha. Okay, I think at some point I start talking about, yes, here we go. So this is going to hopefully kind of tie together our ideas. What would our interval look like based on in relationship to the null hypothesis based on these decisions? Okay, so the question is the null hypothesis, would the null hypothesis be in the interval or would it not be in the interval? Okay, so let's discuss that. If I make an interval such as this, where that was my lower bound and this is my upper bound, and it contained that null hypothesis, then I obviously have a p hat, see? Then I obviously have a sample, that was my estimate, okay, that I used to add up the margin of error to get the top bound, subtract down to get the lower bound. So obviously, this sample was close enough to the null hypothesis that the null hypothesis is within my margin of error. So that situation is one where I would not reject the null hypothesis, and because the null hypothesis is in my interval. So if it is located in the interval, then that is not a significant situation. Okay? And then over here, so if it is not in the interval, okay, so let's see what that looks like. If I made an interval, say I got a p hat right here, and when I add plus or minus my margin of error, my lower bound is here and my upper bound is here. So what is the relationship? This null hypothesis is not in my interval. And see, I would have made a decision to reject the null. So then that's why that goes there. Okay, so hopefully that picture will clarify that relationship between statistically significant and whether the null hypothesis is in the interval or not. Okay, so I'm not going to answer the rest of these. I want you to go ahead and look at 9 through 14, and they'll show up on the video or the notes, and then I'll probably talk about them when I go over the assignment for day 10, which is the warm up for the quiz that you will have. All right, so I hope that that helped you today understand that test, decision, and confidence interval relationship